Hello, my name is Kumar Abhinav. I am a Gen AI software engineer based in Palo Alto, California. AI alignment matters to me because AI systems are no longer just answering questions. They can now use tools, write codes, interact with with other softwares, and carry out multi-stage tasks. In my own work, I built AI assistants, RAG systems, and agentic workflows using LLM models and framework like LangGraph, LangChains. That experience has made me one thing very clear to me. When an AI system can take actions, even a small mistake can have a much larger impact. This is not only a theoretical concern. AI companies are actively testing the system for exactly these kind of risks. And Traffic has just reported cases where Claude unexpectedly found ways outside a sandbox during controlled evaluations. OpenAI test models in isolated cybersecurity environments where they must reason across multiple systems. Google has tested agents against malicious instructions hidden inside external content that try to redirect the agent to expose sensitive information. These are the control safety tests, but they show why capable agents need strong boundaries, monitoring, and meaningful human oversights. For me, alignment does not mean making AI less capable. It means making sure that these systems become more capable. We can understand, monitor, and control what they actually do. One AI AF research direction that especially interests me is region-based deception. My understanding of the work is that simply training a model to give a polite refusal does not mean that the model has learned the right safety principles. It may have learned what a safe look answer should sound like. AIAF works on region-based refusal is interesting because it asks the model to explain why something is harmful instead of only saying no. My main critique is that an explanation by itself may still not be okay. A model can give us a convincing explanation that does not accurately represent the process that produced its action. So I would like to explain this direction by connecting stated regions with evidence we can independently inspect. For a tool using agent, the evidence could include which tool it called, which information it accessed, what actions it attempted, and a replayable record of important decisions. Then we could compare what the model says it intended to do and what actually it did. One experiment, what I would like to try, would place agents in controlled sandbox and compare three groups. The first group would be trained mainly to refuse unsafe tasks. The second group would be required to explain why that task is unsafe. And the third provide both an explanation and a verifiable evidence of its actions. I would then measure unsafe behavior, attempt to bypass restrictions, the accuracy of their explanations, and whether safe behavior continues during longer, more complicated tasks. This direction interests me because it connects alignment research with practical engineering. I want to build. I want to help build AI systems where trust does not depend on what the model says. We should be able to inspect what it did and verify that two matches. Thank you so much for considering my application.